Now in today's class, we'll try to see further kind of protocols. Another one is timestamp based protocols. So in timestamp based protocols, we are going to execute the transactions. On the order of timestamps. On the order of timestamps. I mean, the order in which they are coming, in the same order only they are going to be executed. Right? What is the meaning of basically timestamp? It can be simply a kind of a time, right? System time, right? So basically, if I say 10 o'clock or 10 a.m. or 12 a.m., right? We can call simply as a kind of timestamp, right? Or if you want, you can able to have some kind of unique identification data also. There is no problem. It can be anything, right? But for the sake of your understandability, I am trying to take only time, right? If I am saying that transaction Ti timestamp is something like this, and if I am going to write some relation timestamp of Tj, what is the meaning of this one? Ti is the older transaction. T is the older transaction, and Tj is the newer transaction. Am I right or not? If I say that timestamp of Ti is 10 a.m., timestamp of Tj is 11 a.m. Which one is birth earlier? Ti is the birth earlier, right? So I can call simply as older and newer, right? Now, in this point of time, what they are trying to say now, whatever the conflicts that are occurring, conflicts means what? It can be a read write. Whatever the conflicts that are occurring, those conflicts, if they are going to be executed in the order of timestamps, then definitely there is no problem for us. Why there is no problem? If I say transaction T1 and transaction T2, transaction T1 arrived at 10 a.m. Transaction T2 arrived at 12 a.m. Right? So for example, I am trying to perform write operation. So single transaction, there is no problem. Some other came and trying to perform one more write operation. Is there any effect for you? There is no problem because they are independent. When you are going to have a problem, when you are going to have more than two operations, right? More than two operations means if I say again here double, is there any problem? No. Why there is no problem in this particular time? It is equivalent to serial schedule, right? It is equal to serial schedule, there is no problem. Because serial schedule not going to have any kind of conflicts. Conflicts doesn't mean that there is no problem for serial schedules, right? If I say trying to write read operation, is it now serializability? Probably not, right? Because it is going to be executed in concurrent schedules, right? And is there any problem for us if you are going to execute in the timestamp ordering protocols? Now T1 is older transaction, T2 is newer transaction, right? Now for this, the equivalent serializability schedule is what? T1 followed by T2, write read followed by write, or T1 or something like T2 followed by T1, that is write followed by write read. There is no problem. But if you are going to get this kind of situation, I try to execute the write operation, done. If I try to perform the read operation, meanwhile, have you observed this kind of problem anywhere? Dirty read problem. What is the meaning of dirty read problem? If there is any write read conflict, definitely there is going to be dirty read problem. Before going to uncommit, if I try to read it, definitely it is going to be dirty read. Right? If you are not able to remember it, if you try to observe this one, if I take write, is it a kind of conflict or not? What kind of conflict this one? This is going to be a kind of last update problem. Concurrency problems we have seen earlier, right? So we can get the last update problem. Why you are getting this last update problem? Because without committing operation, that is one problem. So in another way, if I try to say the timestamp of T2 is more than timestamp of T1 with respect to write operation. At that situation also, you are going to have a problem. I hope you understood, right? So what situation you have to have face compulsory? They has to be in ascending order of its execution, ascending order of the timestamps. If any conflict operations are going to be executed, they has to be executed in ascending order of their timestamps. Otherwise, what you have to do? As there might be a problem, you have to compulsory have a rollback, or you have to compulsory abort the transaction. Because as you are trying to say that there might be a problem, compulsory you have to get back to the old situation. So what we can do now? You can simply roll back it, right? Roll back it. Once you roll back it, what about the execution of T2? T2 also be rollback. Or if I say they are going to be start once again with a new state, so T2 is going to be executed, then T1 will comes with another transaction. Let me take the transaction name as T3. Then it is going to perform write followed by write. Okay, now so if I am trying to say in terms of some definition, so you can note down this: priority of older transaction is higher, so they are going to be executed first. So it executes first in timestamp ordering protocol. So I am saying that simply they are going to be executing the ascending order of the protocols, right? So in other terminology, if I say whatever the conflicting operations are there, something like write read, write write, or read write are going to be executed in which order? Executed in the timestamp ordering protocols. Are going to be executed in the timestamp order. Otherwise, if they are not going to be executed in the timestamp order, what you have to do? You have to simply roll back. Otherwise, you have to simply roll back, or I can say that simply reject it. And we have to start with new timestamp. I hope you understood this particular point with this example. Am I right or not? Here, as T1 is trying to get some kind of conflict operation with respect to timestamp, I started with again a new timestamp for the T1. But what about for T2? T2 is 12 AM only. T3 is something like 1 PM. This is what called as a timestamp ordering protocol, right? So meaning that simply the like conflict operation should be occurred in the ascending order, right? As they are going to be occurred in the ascending order, or as they are going to occur in the increasing order of their timestamps, indirectly we are going to achieving the mechanism of serializability. Am I right or not? See, if you are able to observe this one, this is a kind of concurrent transactions. But as I have overridden this one with respect to timestamp, we got a serializability or not, right? Indirectly we are trying to achieve the concept of serializability. That is the advantage of timestamp ordering protocol. In timestamp ordering protocol, we are going to get the achieving mechanism of serializability, and also it is going to be free from deadlocks. It is going to be free from the deadlocks. But what might be the drawback? If I say, meanwhile, some other transaction T4 come, and T4 performs some read operation. Try to observe. At this point of time, some read operation done. Again, what will happen? After this read operation, again T3 has to be executed. But according to timestamp ordering protocol, this write operation is a older one. It is not executed first. So again, it has to be rolled back. So then what will happen? T2 will execute first, then T4 will execute, then T3 will execute, right? Meaning that the problem here is starvation for older transaction. There will be the starvation for the older transaction. Starvation means what? It is in hungry mode. Always I need to complete, right? So that is what we call as simply the problem, right? Or we can say that if there is a starvation, or if there is any kind of conflict operation, we have to make it rollback always, right? More number of rollbacks or more number of abort operations are going to be happen in this timestamp ordering protocol. Right? So to overcome this drawback, one author come up with a solution, like simple some solution. We call the solution as Thomas Wright. So he is simply saying that you have to simply ignore outdated transactions, outdated write operations. I think you are unable to understand anything with respect to this statement. Thomas Wright tool is simply ignore outdated write operations. What might be the outdated write operations? The operations which are completed already, right? With respect to one transaction T. Right? For example, if I say transaction T1, transaction T2, transaction T3, other three transactions. Write operation, write operation, write operation. Is there any problem for this execution in the timestamp ordering protocol? No. For example, 10, 11, 12 AMs. There is no problem, right? For example, if I say something at this point of time, there is a write operation. Then is it going to be violate the timestamp ordering protocol? Yes, because this is first line, second line, third and fourth line. So at what point of time it is going to be violated? Because this point, right? Older transaction is going to be executed late compared to newer transaction. That's the reason it is going to be override, right? So what point is the solution they are saying here? You have to completely roll back this transaction. Then the solution is T2, T3 followed by T4, right? So write. This is one kind of thing. Okay now? Yes. So instead of this, what we can do now? So here we are unnecessarily making the rollback of our transactions by considering this right. Instead of this, what we can do now? For example, let me take, there is a value called 100. Right? If 100 is updated by this person as 101, this person has 102, this person has 103, this person has 104. Now, what the Thomas Wright rule is saying that with respect to one transaction, if there is any old outdated write operation is there, try to make it ignore. Just ignore. You should not roll back. Why I am saying that you have to be ignored? Whether this particular transaction is going to be roll back or not roll back, what might be the final answer? 104, right? So if I simply ignore this transaction, I am not going to execute anything. Simply update by 101, update by 102, then update by 104. My final solution is again 104 only, right? So even if I am going to perform the rollback also. So this is what Thomas Wright rule. So with this kind of rule, we are going to reduce number of rollbacks or aborts. Right? For example, if I say is it kind of thing is allowed? If I say the transaction T1 R1 operation and write to operation. If I say transaction timestamp of T1 is less than timestamp of T2. Is R1 followed by write 2? Is it allowed? In timestamp ordering protocol, is it a allowable one or not allowable? Allowable, right? Read followed by write. There is no problem. If I say read 2 followed by read 1, it is not at all conflicting, so it can be allowable, right? What about write 1 followed by read 2? Allowed or not? Allowed. What about write 1 followed by write 2? Allowed. Good, right? Because they are going to be executed in the order of the transactions wherever the conflict is occurring, right? What might be the not allowed operations? can I say read 2 followed by write 1? Is it allowed? Not allowed. There is a conflict. Read followed by write. Write is older one actually. Write has to be done first, then read. But here it is not happening in this particular case. What about write 2 followed by write 1? Is it allowed? No, it is not going to be allowed. What about the case of write 2 followed by read 1? Not allowed, definitely, right? Because why they are not allowing? They are definitely conflict, and the order of execution of the transactions are going to be not happening in the order of their arriving. Whatever the order they are coming, in the same order they has to be execute the complete order, but they are not coming, so they are not going to be allowed. Right? If I say in Thomas Wright rules, the difference is not allowed comes under is R2 followed by write 1 is allowed, not allowed, and write 2 followed by read 1, not allowed, right? Thomas Wright rule, we are going to always think about only in terms of write operation, right? Yes. So, can I say write 2 followed by write 1 is allowed? Yes, it is going to be allowed. Why it is going to be allowed? Write 1 is the older transaction. Older transaction means it's a kind of something like outdated write operation. Outdated write operations are going to simply ignore it. That's it. So, in addition to above, see, so not only this, you can able to get many situations also. I think all cases are covered, right? No, many cases are there. How many cases are you going to get? Read, write, and 2 transactions. With respect to only 2 operations, you are going to get 4. Another 2, you are going to get 4. Total 16, I think you are going to get. How many kind of possibilities are there? That is what I am trying to convey. Many, right? Or else let me that, right? So if there are any kind of other operations, they are going to be allowed, right? Similarly, all other operations are going to be allowed. Whatever the things that are going to be allowed by timestamp ordering protocol. In addition to that, we are going to allow write 2 followed by write 1 operation also. That is the difference between timestamp ordering protocol and Thomas Wright rule. Okay, now see any other things are there. You are getting some question mark faces. See, read 1 followed by write 2, done. Read 1 followed by write 1. Have you written anywhere? No, right? So like this, you have to check all the cases. So total 16 cases you are going to get. Only 12. So we are not going to get the same kind of operations, huh? Okay, fine. Okay. So this is what the timestamp ordering protocol. Okay. So next concept, shadow paging. Right? Remaining all are not there in the syllabus. Remaining 2 protocols, graph based protocols, multi-granular protocols are not there in the syllabus. Okay. So coming to shadow paging. So what is the meaning of a shadow? Nedana. Simply like in terms of DBMS, same copy. Can I call it as a copy? Yes, right? Yes. So basically, if you try to observe any kind of a disk, or if I say it as a block, it contains your data in the form of a kind of arrange in the form of pages by pages. So if I say this is page 0, page 1, page 2, page 3 and so on, right? So actually this concept is like, I don't know why they have introduced here. It is actually related to completely operating system concept. Okay, so it is a very huge concept also, but for time being I am trying to go with the few with a small example so that you may get idea about this concept, right? So if at all they touch in the question, you can write it, that's it, right? So basically if I say shadow paging means simply maintaining a redundant copy of the data, that's it, right? So how we are going to maintain the redundant copy of data? If somebody is trying to perform some kind of modification, I may maintain a first redundant copy, If I would like to get back to the older data, what I will do? I will simply delete the file what I am trying to write. I will just go with the copy of the older data. That is one thing. Or I will simply place everything in some other location. We can simply call it as redundant only, right? So basically here the concept of shadow paging in DBMS, where you are going to get na. Suppose for example, if I try to say in your point, if I am going to have a book, large book, right? It is going to have pages, right? Page by page, right? And you are going to have only 1 hour of time for your examination. Are you going to read all the pages? No. You may read first few pages, or whichever the page having the important topic, that page you are going to read in this 1 hour of time, right? Similarly, the concept of paging is how they introduce. If I am going to have a RAM size of, for example, 100 MB, there is 1 GB of memory is there, 1 GB of disk is there, right? Now, if I would like to perform some operation over the data, can I able to read this 1 GB of data? No. If you would like to read something, first where it have to be available? It has to be available in the RAM. Right? So I cannot able to get the 1 GB of data into the RAM. So what I will do? I will try to take parts of the disk. Each part of the disk I can call it as a page. So in our terminals I am saying, that's it, right? So block is going to be divided into pages by pages. If I require to have a page 2, I will get the page 2 into my RAM. I will try to perform certain operation over it, and I will try to get back update in the database. That's it, right? So in this particular situation, what is going to be happen? If I am going to take certain data, something like page 2 from disk to the RAM, I am going to simply call it as current page table, or I can say simply current page. Right? In the current page, what you are going to have? Page 2 is there. Now, if I try to perform some kind of modification over here, certain kind of modification, yes, modification done, right? If I am going to update it, that will be updated here. Now, if I would like to get back, if I would like to perform some kind of rollback, after modifying, trying to get rollback, what will happen? Again, it is going to take certain kind of time to get back to the old states, right? So instead of this, what they are trying to say, whenever they are requesting for some kind of a page, before going to go for direct modification in the RAM, try to make the current page as shadow page, meaning that you consider this as a redundant page and create your own new page with the same name as page 2 with the new one. And if you are trying to perform any modifications, those modifications try to perform on this particular new page, meaning that what? I am not going to disturb the existing page. I am not going to disturb the existing page. Instead of that, I am going to modify anything whatever the day here. right? If something is going to be happen and I'm trying to roll back, where it is going to be happen? Always going to be happen in this particular location, right? Yes. If I thought that I don't want to have any data, I'll simply discard this page, right? That's it, right? Now, if I have tried to perform commit operation, that data will be performed commit here also. Once it done commit, the data will be updated in the shadow page. The data will be updated in the shadow page. Now, at this point of time, the shadow page and the current page both are same. So, both are equivalent. Both are equivalent. Once completely commit done, what is the meaning of it? I cannot able to get rollback. At the situation, can I able to remove this block so that this block is free, and if somebody is trying to read some more pages, they can able to occupy this page and they can able to make it as a current page and they can able to try to work. So this is what the concept of shadow paging. Simply, shadow paging is a kind of a technique which is meant for to recover the database. Is a kind of recoverability technique. Right? So at what stage we are going to recover? If something is going to be happen by mistake, if you want to get back to the older data, then you can able to get back by using the shadow paging technique, or some kind of locations where you are going to maintain your data in certain kind of location somewhere. That one we can call it as shallow copy. Shallow copy is different from shadow copy. Shallow copy means what? Existing data you are going to maintain complete redundant at some other location. If something is going to be happen because of calamities to this database, we'll simply redirect it to some other database. That is what we call as shallow copy. Something like if you take manabadi.com, right? You are going to have two servers, server 1 and server 2. If more traffic is available for the S1, server 1, you can able to redirect this traffic to server 2. This server 2 and server 1 both are having the same data. Now, with respect to S2, S1 is shallow copy. With respect to S1, S2 is the shallow copy. Shallow copy means complete data is redundant. Shadow paging means a part of the disk is going to be redundant. Right? So, this is what the concept of shadow paging.